Thank you. So, Chair Courtney and members of the committee, thank you for being here in the middle of the summer. I really appreciate your thoughtfulness in considering these topics. You represent the best. Thank you. I'm Laura Brophy. I direct the Estuary Technical Group at the Institute for Applied Ecology. It's a small nonprofit in Corvallis. I'm also a faculty member at Oregon State and one of the founding members of the Pacific Northwest Coastal Blue Carbon Working Group. And I'm here to tell you about blue carbon, which is carbon that can be stored in our coastal wetlands and how that can help to mitigate climate change. So what we call blue carbon is the carbon that plants take up, as was described for forests, but in this case it's in tidal wetlands, and those could be grassy tidal wetlands like the one in the center of this picture, or they could be forested tidal wetlands like the one on the lower right, or they might be seagrasses even further at the lower right. And the plants take up that material, that carbon, store it in the soil, where it, of course, then doesn't enter the atmosphere. Now, there are some small emissions of carbon from the soils of tidal wetlands, and in our brackish tidal wetlands in particular, those tend to be small. That's why the red arrow on the right is relatively small. By contrast, in non-tidal freshwater wetlands, the amount of greenhouse gases that are emitted from the soil can be higher. Now, those wetlands still do store carbon, but there's more uncertainty about their net effect on climate because of these greenhouse gas emissions, for instance, methane from the soil of some of those other types of wetlands. So we have less certainty in terms of climate effects. So we focus on tidal wetlands for that reason. So how do they stack up in their performance in terms of carbon sequestration? This chart shows how much carbon is stored in different types of ecosystems, and generally, just globally, tidal wetlands store a lot of carbon in the soil. And in fact, up to 10 times more carbon than forests store in their soils. So it's a very high level of carbon storage. And you can see salt marsh is one type of tidal wetland that's shown here, and it stores almost as much carbon in its soil as mangroves do, and mangroves are pretty well renowned for storing a lot of carbon. What's even more exciting, though, than this chart is what we're seeing in the Northwest. And we have actually had a huge information gap for the Northwest, and we're trying to fill it as fast as we can and get information on this. And what we're finding, these are some of our early results from projects in Oregon and Washington. 1.5 to 4 times the global average in terms of carbon storage in tidal wetland soils. So that's pretty exciting. Boone Kaufman at OSU said these stocks are similar to old-growth forest in terms of the quantity of carbon. And what's cool is that carbon's in the soil, and that soil is always wet. And so that means that's permanent storage. We don't have to worry about maybe a building being torn down and material going to a landfill, or forest fires or things like that. So permanence is a big deal in these wetlands. So the situation actually on the ground on the coast of Oregon is more complex than that, even though, because we've actually diked and drained a number of our wetlands. Over half of them, in fact, have been converted to other land uses, which are productive in their own right, but less so for carbon storage. In fact, when they're diked and drained, a lot of carbon is emitted from those wetlands, and that's part of their impact, and it contributes to climate change. On the positive, well, actually, I should explain what this air photo is. This is in the Coos Estuary, and you can see some tidal wetlands in the upper left, and then those orange lines are just drawn on this map to show where dikes are. And the former tidal wetlands behind those dikes are now pastures. And so they have lost some of their soil carbon and are serving different functions, but not as much carbon sequestration. So tidal wetland restoration and tidal wetland conservation can be designed to maximize and preserve carbon storage in our tidal wetlands. And besides that carbon function, tidal wetlands serve a whole lot of other functions, and those are those co-benefits that Kathy mentioned. One of the most important you've probably heard of is supporting salmon. So I've even heard people talk about these tidal wetlands as working lands because they grow fish. So it's an interesting way and important way to think of our tidal wetlands. Flood control is another major function that these wetlands can serve, and I'll give you an example of that in a moment. Water quality improvement, natural infrastructure that supports coastal resilience. Tidal wetlands do a lot for us besides store carbon. Our working group is, I'm not going to go through all the names on this slide, but it's a pretty diverse group of people, scientists like me, but also land use planners and economists and carbon market experts, as well as others of my own ilk, and we come from all different kinds of organizations, government and academia and consulting companies and nonprofits. And our joint goal is to help develop ways to mitigate climate change through carbon market financed restoration and conservation of tidal wetlands. And so we're pretty active, and we're trying to build this data so that we can answer these really critical questions. We have two big projects right now that relate really closely to your committee's interests. One is the development of a database on how much carbon is stored in tidal wetlands. And we're going out and measuring it in over 30 different sites from Northern Cal up into Puget Sound. And we've actually worked with end users to find out what kind of information they needed and what we could gather efficiently. And information on these carbon stocks was #1 priority. So we're starting with that, and we'll share those results online in a web database that anyone can access. That project's going to be done in 2019. And now, at the same time, during the last part of that carbon stocks project, we're doing a feasibility study to figure out how we can move tidal wetland restoration and conservation projects into the carbon market. So how can these be carbon financed? And this is more of an economic study and engages some communities to see how we can get these projects rolling. Also will be completed in 2019. So we're really trying to move this process along. So as an example of a tidal wetland restoration, in Tillamook, this is the Southern Flow Corridor project, which you've probably heard about. It's 500 acres approximately. And this project has a lot of benefits, one of which is flood reduction. But one of its other benefits is carbon storage. And we estimate that this project will probably store 200 tons of carbon per hectare, metric tons. That's about equivalent to 21,000 cars driven for a year. So it is a lot of carbon that's being stored in this project, and we're excited about that. So in summary, Oregon's tidal wetlands do store a lot of carbon. Tidal wetland restoration and conservation can maximize this storage, and that helps to mitigate climate change, and it also provides a whole lot of other benefits to our coastal ecosystems. And our Pacific Northwest Blue Carbon Working Group is trying to fill data gaps as fast and as accurately as we can. And among our projects are these feasibility studies for bringing wetland carbon projects to the market and helping coastal communities reach their goals for conservation and resilience and climate change adaptation in the process. And I have shown my contact info here. If you have more questions, please feel free to contact me. I work really broadly in tidal wetland restoration and conservation and strategic planning, and I'm just at your disposal for questions about tidal wetlands and climate change impacts to them. So thank you.
Thank you. Questions? Yes, Representative Brock-Smith.
Thank you. I really appreciate your presentation and the discussion on, of course, the tidal wetlands and, of course, how they do, they're huge carbon sinks, and the possibilities of moving forward with conversations on how we can work towards public-private partnerships within those tidal wetlands and offer some on-end restoration, which could be very beneficial across the spectrum and the economies on the coast. So, thank you.
I appreciate that. Coos Bay has been a leader in this area.
Representative Rushke, please.
Thank you, Mr. Chair, and thank you for your presentation. There was a slide there I wanted to take a look at. It said tidal wetlands remove and store up to 10 times more carbon in the soil than forests. That's the slide. Thank you. And my question is of point of clarification. So in our testimony from our last committee meeting by Peter Doherty, he said that basically half of carbon is stored in the soil for forests and the other half stored in the wood stock of the trees themselves. And so it looks like tidal wetlands store all their carbon in the soil. Is that correct? Am I understanding that correct?
Almost.
And then I want to know, are we comparing just the soils, or are we comparing the soil of tidal wetlands to all of forest, which is the tree stock and the soil?
In this case, my little blue box on the right is 10 times more carbon in the soil than forests store in their soils.
In the soil. Okay, thank you. That was my question.
Okay.
Thank you.
You're welcome.
Senator Devereaux.
Thanks, Mr. Chair. Thank you very much for that presentation. Really eye-opening for me. Could you tell us who your colleagues are in the Pacific Northwest Working Group?
It is a really long list.
Oh, okay. Well, no, you don't.
But national estuarine research reserves like South Slough, which was the first of the reserves in this country, are kind of leading this effort, along with my small nonprofit, which is coordinating it. Craig Cornu is the contact here. And then we have a bunch of these different estuary partnerships, which are nonprofit and in some cases sort of, well, I can tell you, for instance, for the Columbia River Estuary, these are very important organizations in the region that lead conservation and tidal wetland restoration activities. Universities, these climate trust and groups like Sylvestrum are climate-specific organizations.
Yeah, I was just wondering, actually, if it extends to British Columbia as well.
Oh, I'm sorry, I answered
No,
a
that's
different
fine.
question. We are really just Oregon, Washington, and California
Okay.
at this point.
Yeah, great, thank you.
Representative Power.
Thank you. I'm wondering, for those of us who are not experts in calculating the carbon value of tidal wetlands, because you mentioned they're superior and obviously Oregon's look fantastic. What tools or processes are used to calculate the carbon value?
Oh, thank you. That's a great question. Well, we take carbon cores, we take soil cores from the ground, and then we measure the amount of different isotopes in them, and those isotopes' decay rates help us understand how long it took for the amount of carbon that we measure in the soil core to accumulate. So it's a pretty technical process, but we basically just measure stuff in the soil and then try and figure out how long it took to get there and how much total there is. So we can determine not just the amount of carbon stored, but how long, how quickly it got stored as well, which is important for these carbon markets.
Representative Helm.
Thank you, Mr. Co-Chair. Another question of scope. Do we have an estimate about the total number of hectares of potential restoration area in Oregon?
We have a total of about 35 to 36,000 acres of area within tidal range in Oregon, and over half of that has been converted to other uses. So 15 to 20,000 acres, I would guess, just very roughly.
Any further questions?